Synapse again for providing coffee for the conversation, networking, exercise, and visiting the different booths from our sponsors and exhibitors. I'd like to announce that the security workshop is full, unfortunately, or fortunately, because there were a lot of people interested in the workshop. Now, if you want to sign up for the other workshops, you must do so through the website and not the app. So if you want to take part in the workshops this afternoon, and they are listed on page 8 of your program, please do it through the website. So as you realize, we're a bit short on time, so we'll get right into the next session, which the theme, I believe, is on the screen. It's coming up on the screen. So I'd like to introduce our moderator for this session. We're happy to welcome Anne-Marie Pellerin, Managing Partner at LAM LHA Consulting. LAMLA. Yes, that sounds very good. LAMLA. Anne-Marie is actually the founder of LAMLA, and she combines strategic thinking and technical know-how to advise senior executives on some of the most pressing challenges and opportunities in the aviation and security sectors. Having served as a senior executive in the U.S. Department of Homeland Security in both the U.S. and Europe, she is uniquely positioned to navigate U.S., European, and global regulatory environments and related trends. As part of her time at DHS, Anne-Marie served as Executive Director of the Checkpoint of the Future program, with which we're quite familiar, and she was tasked with overhauling the agency's passenger security strategy and launching multiple new domestic and international partnership initiatives, including security scanner advanced X-ray deployment, mobile boarding pass, and risk-based passenger screening. So Anne-Marie, it's all yours. Thank you.
So good morning, it's still morning. You've had your coffee, we're not yet at lunch, so everyone's still awake. Thank you so much for having us here today. We have a great group. We're actually going to go around and let everyone introduce themselves. And after that, we have a short video clip, and then we will talk a little bit about some of the polling questions that we have. We have about 45 minutes on this panel, and we're going to talk about aviation, security, innovation, and the future. So to start with our first panelist.
Thank you, Anne-Marie. I'm David Atkinson. I'm a senior research scientist at the Pacific Northwest National Laboratory, which is a United States Department of Energy research laboratory. I've been involved with innovation and technology development for aviation security for about 30 years.
Good morning. My name is Sarah Snar. I'm here as part of the Future Aviation Security Solutions Programme, which is a UK-based government-funded programme between the Home Office and Department for Transport.
Good morning. I'm from Kenya. My name is Beatrice Mudhoga, working for Kenya Airports Authority. I'm currently the Assistant Security Manager based at Jomo Kenyatta International Airport. Thank you.
Hi, I'm Amanda Fond. I'm a technical support contractor for the Department of Homeland Security Science and Technology Mission Capability Support Division, and the focus is aviation security.
Good morning, everyone. My name is Bruno Faviero. I'm the CEO and co-founder of Synapse Technology. We develop artificial intelligence systems to automatically detect prohibited items in X-rays of baggage.
Thank you to everyone for the introductions. Before we get started with the questions and the discussion, which I think was going to be somewhat informal between the panelists, I wanted to show a short video clip.
Apriete que ahora celebra, mijo, perdió el colombiano. Perdió el colombiano la medalla de oro. Ahora celebra, mijo, ahora. Primero hay que pasar la raya. A ver, esto es para repetición, pero para mí el colombiano...
Quedó descalificado, inclusive. No, descalificado.
¿Estaba descalificado quién? ¿El colombiano?
Sí, Alex. Lo descalificaron a Alex.
Ganó Corea, Colombia no puede perder.
So that was a very quick clip. But the point of the clip, and I hope you saw this, is the person who was celebrating in the race, who thought he had won, in fact lost because someone surpassed him. So I think this makes a valid point about acceleration of innovation in the industry. If we become too confident that our baseline security practices and the measures that we have in place are rock solid and our adversaries are not going to get beyond it, then eventually they'll get beyond it. So today we want to talk a little bit about how do we deploy capabilities more quickly into the field, how do we drive innovation among our stakeholders, and how do we incentivize the upgrade of capabilities in the field through new and innovative approaches to policy, to testing and evaluation, and to research and development. So to start our discussion, to grab my notes, I wanted to start with the R&D kind of topic area. So Dave was talking earlier this morning about the infamous valley of death, this kind of valley between research and development activities for small to medium-sized companies and investing funds into building technologies, and an acquisition of those capabilities years later. So how do small to medium-sized vendors kind of get through that valley of death without kind of falling out so that we actually don't have the ability to have those new and innovative capabilities in the market? Does someone want to address that question? Yeah.
So the Valley of Death is an interesting concept because I think part of the reason there have been such a conglomeration of businesses in aviation security is because historically the main solutions were large hardware systems. And when you're building large hardware systems, you can't do that very quickly, you can't change them very quickly. And so you need very long-term roadmaps, you need a lot of money in the bank, and if you're a small company, you might not have 3, 4, 5, 8 years from when you start developing a product to when you deploy it. And I think that the technology is changing and it's becoming more agile, and we need to look at how do agile processes keep up with technology. So now that you have the ability for software to improve quickly, to be deployed rapidly, there are opportunities to start addressing that valley of death between low TRL levels and when it gets deployed.
Feedback loops, tight feedback loops sounds like the answer. So looking at PNNL, kind of another opportunities for governments or national laboratories to also assist with this problem, what would you have to say?
So one thing we always have to keep in mind is that the companies in this business are businesses. They have to make money to stay in business. We like to talk about collaboration, harmonization, and things that brings the uniqueness and gets everybody on what we call level playing field or the same page or whatever euphemism you want to use. But in the end, companies survive by being innovative and different from their competitors. And so we have to delineate having processes that puts everybody on the same page with allowing companies to innovate and bring new things to the table. I think one of the good approaches is to fail quick and not have technologies that you linger on for years and years. We try at our laboratory to very quickly get rid of technologies that really don't look like they're going to go anywhere. The physics doesn't support it, or they'll never meet the ConOps, meaning a measurement that's going to take 5 minutes to happen. You have to quickly get rid of these potential solutions as non-solutions, and that's a very hard thing to do. If you're invested and you've invested 2 years of money, to say we're going to kill that program because we don't think it's going to get there is a hard thing to do. So there is some hard decisions that have to be made in this process.
So to kind of build on that point and looking at kind of what the regulatory community can do or what at the international level, the international community can do to actually kind of very clearly lay out what the long-term objectives are for the technology and the capabilities and kind of how research and development funds will be spent and what in the kind of airport and airline operator community stakeholders can do to actually facilitate the testing and evaluation or the kind of operationalization of these technologies in the field. So Amanda, do you want to address that from a DHS S&T perspective?
Sure. From a DHS S&T perspective, so we typically focus on technologies that are technology readiness level about 2 through 6, and then it transitions to TSA. As Keith mentioned earlier, TSA has the Innovation Task Force, which is a public-private partnership, which gets technologies out into the field earlier, and you get feedback from airports, passengers, et cetera, and then we can easily determine if the technology fits the ConOps and operational environment.
You have the ITF with the United States government. The UK also has this very similar program known as FAST. And in FAST, I know that there are a number of priorities for the UK government in terms of different capabilities that you'd like to see in the market and how you develop your selection strategies around that. Do you want to comment on how you guys kind of walk through that process, Sarah?
Hi, yeah, so for us in terms of understanding the gaps and the capabilities, it's really about knowing our program and truly what we have invested in, what there is available out there that we could invest in. So it's that engagement with both suppliers and industry, the airports and airlines, understanding what they need as well as what they want from a more operational perspective, not necessarily along the security regulatory sides, but the things that are going to help them make life a little bit easier in the operational front. And equally for us, it's about ensuring that we're covering all bases. There's a lot of new innovative technology out there, but interestingly, there's a lot of technology that already exists that we could incorporate in a different way. We can bring on board different training for staff and things like that. So it's just making sure that we're engaged with both the suppliers that are bringing these solutions to us and the airlines that need and want them, and understanding that full picture.
So it seems like, we've heard from PNNL, from the FAST program, from DHS S&T and ITF. It's very clear in terms of how you guys are building your selection criteria for new and emerging capabilities. But it seems like there's a role for industry to play as well, and for the technology providers in terms of how you go after those processes, what you communicate to regulators in terms of what your capabilities are. Do you want to communicate on that, Bruno?
I think as technology is changing, because the feedback loops get tighter, we can't afford to just wait 2 years to watch what other people do, because aviation security is a very unique industry. And so what people are building in other industries, you're no longer going to be able to just take what they're doing and use it here. And so when you think about artificial intelligence, it's really an opportunity for everyone involved to say, what do I want it to do for us? And what do I want to see in the short term? Because the technology exists today, and it can be deployed in a way that if you were to deploy it today, see how it works for 6 months, and then have this loop where you then update the regulation, it's going to look much, much different, and it's going to look much closer to what people actually want than if you spend a year thinking about it and then deploy it for a year and then go back to the drawing board. With the adversaries being so agile, there's an opportunity here for more people than just the regulators, every airport, every airline, every operator, to give feedback into what tools they wish they had that can be tried tomorrow.
But it sounds like that's applicable for technologies. It's also applicable for processes, right? So as we try to get out of just thinking about innovation in terms of technology deployments and look more at processes, at training, and other activities in aviation security, Beatrice, what do you think on that front in terms of inspiring innovation?
In terms of processes, I would specifically discuss the screeners, because all this technology at the end of the day comes down to the screeners. And if states deploy very good technology without capacity building, then it doesn't work well. So we would look into developing capacity for the screeners, minding what that screener exactly wanted. And I think of importance is also that the end user is engaged by the technology provider, so that at the end of the day the process user gets exactly what meets their demand. Because sometimes you find technology providers who provide technology that does not close the gap that the provider needed. So I think that collaboration and proper research of what the provider needed is of what the process owner needed is very important, and it's very key. So for screeners for incentives to the screeners, if I may discuss that, is that they need proper training for the technology that is being provided to them, and that would make them more motivated to use that technology. Thank you.
And the technologies we talk about should not only be just about the things we want to deploy. There are supporting technologies that can bring a lot to the table here. As we talk about screeners, I think we're going to see things like augmented reality, virtual reality becoming a big part of training screeners, because you can put them in a variety of situations very quickly, very uniformly, so people are screened the same way. You don't have to have large infrastructure with a checkpoint simulator. It can all be done in virtual reality. I think these kind of technologies are going to really help push the enterprise, security enterprise forward in the coming years.
So we've talked a lot about kind of iteration, moving away from waterfall and becoming more agile and tight feedback loops related to technology, but also processes. I like to say it's 20% technology, 80% people, process, and politics. So if we kind of take it up a notch and look at the international community and ICAO and ICAO's role in all of this, and what we can do. We talked earlier in a panel about maintaining or building a baseline detection standard internationally. In terms of international best practices or other activities that ICAO could undertake to drive acceleration, do you guys have some thoughts on that?
One of the areas I think ICAO can help would be information sharing. For instance, as we're going towards deep learning, machine learning, one of the big issues is having large data sets. So if the community could perhaps maybe share images that everyone can use, the more information, the better your machine learning algorithm.
And just to add on that, I think states are also left to decide on what fits them best. If ICAO could also give information on what technology has better capability than the other, I think that also could help the states.
And there are still some huge scientific challenges that ICAO and the member states can help with. For example, training aids for canines, trace standards are still very much in their infancy, and I think a consolidated international effort is going to be needed scientifically to solve some of those difficult problems.
Yeah, and I think if you were to introduce new standards, global standards, you run into the new challenge of how do you measure that? How do you measure the baseline? How do you measure the improvement? How do you measure adherence to standards? In the software world, we have a saying that you can't improve what you can't measure. So even if you were to introduce artificial intelligence that detects more guns and more knives, how do you really know how much different that was than what you had before? If you have a system that makes operators less tired, more motivated, less likely to leave their job, how do you really measure that and the impact that that has on not just security and the ability to find objects, but the passenger experience, which has a lot of downstream added value?
There's value to be had in sharing the knowledge about what technology is actually out there and what is currently being tested and evaluated in different areas of the world. Other areas, there are many things that are being tested in the United States, for example, that the UK are working on much lower level technology levels, and we're not aware that you guys are actually already currently testing in this information. So it's definitely knowledge of that would be definitely useful.
And I'll add one more thing. I think being able to understand the differences between the different environments. Somebody this morning said if you've seen one airport, you've seen one airport, and that really is true. The commodities that go through, the stream of commerce, the local conditions when you deal with things like trace detection, all impact how the measurement is made and how successful it is. And it's hard to build a standard that takes all of those conditions into account. And certainly looking at that across all the airports in the world and understanding which ones are important and which ones aren't is a good activity to do.
And so kind of building on that point, if you've seen one airport, you've seen one airport. When we look at new and innovative capabilities that are being deployed in the field, we often hear the same large airport names that are trialing these technologies, right? So how do we actually push out some of that innovation to the smaller locations, to the smaller airports? And what do the smaller airports actually want? What are they concerned with, and what's on top of mind? Beatrice?
To remember that in as much as we have already developed countries with very developed airport, we also have airports that are still struggling to come up, and their priority may not actually be technology but even growth. So, but still they can still they can still come up in ways of how they can also develop and catch up with other airports. And one of the way they can do that is through private-public partnership. And then they can also partner with airline and other stakeholders. They can also look for funding from, say, United Nations, World Bank, and such kind of companies. Yeah.
That's where I think as well, Anne-Marie, with these capabilities becoming more agile and they can be developed more quickly, there's an opportunity here for, honestly, every airport in this room to influence what the TSA is looking at, what FAST is looking at. You know, these types of developments and experiments and trials don't anymore have to happen in these labs that have multi-million dollar funds. A lot of times what new technologies need in some cases is data or just access or information about what they want, or more often than not just feedback on what would you actually use, and anyone is capable of working with a startup or a new technology in that regard.
And in small airports tend to be more cost conscious. They don't have to have the hottest, shiniest new instrument off the line. They tend to have lower throughputs, and so they can live with technology that has good detection metrics but might be slower because they don't have the throughput to deal with that a bigger airport might need to. So we need to keep these things in mind, that all technologies don't fit one template.
In as much as we say that a small airport may have less throughput, we would also want to consider that the specifications that are given by some states like TSA, some of these small airports may not even be able to buy technology that meets those specifications. So I think that should also be an area of consideration, because if from a small airport a certain technology could work for them, but then the specification from some of the states like AU and TSA is quite in another level, then it leaves a gap that needs to be addressed.
And it sounds like in terms of airports not necessarily being able to afford or deploy certain capabilities at a minimum, and I think we've seen a lot of progress in this field in the last 3 to 4 years, is really understanding your risk environment and what the effective countermeasures are that you can deploy to buy down risk. And there's definitely not a one-size-fits-all solution, right? So if you have a menu of options that you can deploy in those locations and people think outside of the box in respect to how they do that with an outcomes-based focus, there's real opportunity. And we've seen a lot of progress in that space. So kind of moving beyond kind of iteration and finding airport stakeholders to work with, I want to talk a little bit about testing and evaluation, because that routinely comes up in conversations. It was a big topic in the last panel around how we can streamline that process and how we can help to kind of allow technology vendors to invest less in administrivia and red tape of T&E and take those same savings and reinvest in the development of new capabilities.
Okay. So it's easy to phase this so that you don't spend time and money. As I said earlier, fail big and fail early is not a bad thing, because you can weed out technologies that aren't going to make it. So in a way, you need to have multiple levels of T&E, at a developmental level, say developmental T&E, so you can weed things out that obvious the physics or chemistry aren't going to get there, before you get to a more stringent operational environment type of testing for a certification or a qualification. Having multiple layers where you can weed things out very quickly will save money and time and effort in the long run.
I think from a FAS perspective, it's the consultation piece with industry and with airports that's key in the testing and trialing, not only the availability for airports to allow us access to test and trial. But also understanding that there's a supplier buy-in in this. We need to understand that they have to input resource and effort in order to advance this technology. And I think from a government perspective, we not only sometimes have the opportunity to fund it, but we need to be there to support that relationship and ensuring that both sides are clearly communicated on exactly what they're trying to get out of that test and trial.
To streamline testing, there's a few things. One would be to have third-party testing. The problem is that third-party testing has to be done with the same rigor that the TSA or ECAC testing is going to be done in. Therefore, hopefully it will help when you deliver your technology to the TSA for qualification and certification testing. It will streamline that process because it's already gone through rigorous testing. In addition, you can also do testing of independent components in parallel. Say you have an algorithm and a GUI. They don't necessarily need to be tested at the same time. They could be done in parallel to make the process more efficient.
From a FAS perspective, we're from the UK trying to develop a framework so that we can be really clear on exactly what technology and solutions we're looking to test and trial. And within this, we are taking the approach of not only looking at the security and capability benefits, but also the benefits from an operational perspective for the airports and airlines. There needs to be an incentive for them in terms of some of that capability considered the same level as the baseline we've got. So why would they buy it? Why would they take on board this technology and use it within their own airport? So we need to be clear in what we're choosing to test and trial, showing people the clear benefits and outcomes of everything, all the holistic measures that can help the airports.
One other thing we need to be aware of, because this is a competitive business, is that tests need to be unbiased and they can't sort of lean towards one technology or another. You know, each of the companies has its own little take on the physics or chemistry of how something works and how the measurement's made, and it's very easy to have a test that favors one instrument without even thinking about it. And so we need to be very thoughtful about how we design the test to ensure it really is fair, not just mimic the operational environment and simulate the threat.
Okay. So another point, I think all of you in this room know that passenger facilitation solutions are all the rage. But when you look at kind of clear, pure detection solutions, how do you find the IED? How do you find prohibited items? How do you find IED components? Going to an airport and getting an airport to care about helping you test in an operational environment your technology, it's challenging. And I can understand. So if you're an airport VP of security and someone comes to you and says, I want you to trial this technology in your operational environment, it's going to cost you time and energy and money, and hey, by the way, you're not required to do it, but it could potentially enhance your security, how can the regulatory community and ICAO and others create an incentive structure to help airports actually take the plunge and trial and help get more technologies to market faster on the detection side?
And I think part of that solution is looking at what are innovative ways we can solve those problems in addition to solving them directly. So directly, I mean, there's a lot of people working on how do we directly detect explosives in components with new hardware, new sensors. But until those get built, until those get deployed, what else can you do? A big hypothesis for us is research has shown that the more objects that operators have to look for, the worse they are at finding any one of those particular items. Yet threats are moving. The biggest threats are no longer as much metallic items and guns and sharps. They're starting to be those liquid explosives, solid explosives, powder explosives. And one approach that we have to detecting more of those types of most dangerous items is to have the operator focus on those and have the AI do everything else. Can we offload the cognitive burden of these operators who are overwhelmed? They're tired. They are anxious. The burden is on them. If a plane goes down and they miss that bomb, they're distracted. They have long shifts. So the more we can do to reduce the number of work that these operators have to do, to have them work smarter and not just do more with the same constraints they've always had, I think we get to more holistic, effective security.
So there's a couple good things going on that helps facilitate this. Number one is there's been a number of airports going through remodels, and in those remodel phases, they're opening up space for security operations, bigger footprint than we've ever had before. Some of the older legacy airports, of course, have very little room to test new equipment or set up a pilot screening area, but with some of the remodels and new terminals being built, we'll have that opportunity to have the open space to do it. The good thing is the airports are competitive about this. Each airport wants to be known as a leader in security. When I talk to the Port Authority and the law enforcement people at the airports, they're very proud of their track record with respect to finding threats and keeping people safe. So certainly convincing them, and once they have the space, that they should take this pilot on is not that difficult. Then it just comes down to funding and support to ensure it happens. And on the passenger side, by, say, having a pilot screening area, but the line is a lot shorter, sort of like pre-check, would incentivize passengers to say, hey, I'd love to go through this. It'll get me through that line so much faster. And so using those kind of incentives is a good carrot to move things along for testing in the real environment.
So speaking of carrots, we have a poll that's open now. So if everyone could kind of go and look at the polling questions on the app, that would be fantastic. Incentive structures. So when we look at regulatory requirements that are levied in the aviation security environment, often airports or operators are told what they must do. I think in recent years, an interesting evolution we've seen is that regulations are being written to create a business case for certain large airports to roll out new capabilities. So one example of that would be CT at Checkpoint Solutions in Europe, with a new C3 standard that if you as an airport deploy a C3 capable CT system, passengers can leave laptops and liquids in the bag, which all of you know is a huge value to an airport operator. So therefore, operators are not required to buy CT at Checkpoint systems, but the business case is there. So are there other ways that operators or regulators can start to look at incentive structures in the aviation security environment, or how they can deploy new systems in a way that they're not necessarily required, but there's a benefit? Anybody? Dave? You don't want to talk?
So going back to you've seen one airport, there are some specific challenges at certain airports. The one I'm keenly aware of is the cruise ship traffic at Seattle. And there are certain times of the year where their traffic literally doubles and all the ships come in the same time. And this is where they really have security line problems because of that big influx. Certainly they are incentivized to try new things. And if we can identify challenges at each airport that the new technology or the new ConOps approaches are focused on helping them with their specific problem, whether it be throughput, whether it be a specific commodity item, whether it be a specific passenger item that's carried, like skis into Jackson Hole in the winter, that we want to screen quicker and faster, but they're big and bulky. I think the incentives are there if you target it individually and not say, we're going to put out an innovation that's going to work system-wide. There is certainly room for innovation for specific airports.
Yeah, and I think it's interesting here looking at the poll that the majority of the interest is in better communicating the advantages of new technologies and financing more pilots. And I think something ICAO could do as well is encouraging more pilots, because when you have more data points, when you can see how does the technology actually work, you're no longer guessing and you're moving on to the next most challenging problem. We've been very fortunate to work in Japan where they've been pioneers of AI, and the biggest AI trial we've done with Narita Airport at actually deploying an AI that works alongside operators to detect guns and knives automatically. And it mirrors what we see in the industry, where if you have an AI that is helping the human is training that AI for the long term. And now the challenge is no longer, would it ever work? Can an AI actually do this? It's how can we make it work best? How can we make the integration work? How can we make open architectures enable more developments like this and move away from closed systems that depend on lengthy procurement cycles?
Yeah, that's a good point. Certainly, to be able to pilot new technology, having an open architecture system where things can be plugged in and they're going to work right off the bat because the system knows what to expect is a big deal. And innovation certainly gets slowed by proprietary systems that don't interact with the other part of the enterprise. So I think the open architecture is going to be a big push in the future. That's going to be very important.
Comment on open architecture. And this way, too, you wouldn't have to require technologies to basically plug in the open architecture, but it'd be advantageous to their business model to do so.
Yeah, no, just quickly, I think we have talked a lot about incentive structures. It feels like there is a lot of, in the ICAO community, a lot of capacity development work that's actually done as well. A lot of training by the international community out to the aviation security sector. I guess a question, Beatrice, for you is, when we look at capacity development activities in different smaller airport locations, and we think about how the money is flowing to strictly training activities, is it possible that in the future we could imagine some of that money also potentially flowing to technology capabilities coupled with a human to actually make the human more effective?
Certainly, yes, because technology will come to support the human element. So when technology is employed in an airport, then it supports what the human are doing, and so it increases efficiency, and it also motivates screeners because they don't have to do everything by themselves. So technology is certainly something that should be encouraged, even in the small airports. Yes.
So we talked about the incentive structures, or the carrots, so to speak. One other thing that is starting to work out quite well, and you're going to see more of it, is prize competitions. So the prize competitions enable a block of money to go a lot farther than it would in a standard fund a number of performers and wait and see what the results are and decide which work better. In a prize competition, you only give money to the winner. And this has been around for a while. DARPA did this for many years, but you're starting to see more and more. We were recently involved with one with Kaggle, which is a Google spin-out related to millimeter wave body scanning, AIT, that worked out very well. And you need a good data set to do it, but you can put it out there for everybody in the world to innovate on, and you'd be surprised what you get and who actually works on the problem, on an interesting problem like that. So prize competitions are an up-and-coming wave that I think are valued, and ICAO could have a big role in helping set those up for sure.
Again, I'd like to add to what Dave said. So the Kaggle Prize Competition was actually co-funded by Department of Homeland Security, Science and Technology, and the TSA. And what we did was published, I believe it was about 1,000 millimeter wave images for everyone to train algorithms on. You then submitted your algorithm, and then the algorithms were tested and evaluated against 500 additional images. There were about 500 algorithms submitted, and then the top 8 received a monetary prize. So again, it not only, I guess, encourages innovation, but also we received a lot of non-traditional performers that don't go through the long-range broad agency announcements. It's not the typical transactional authority that we use. So,
and I think when you have programs like that, you can start having, the airports, the airlines, the different stakeholders honestly raise their expectations. When you buy a machine, can it talk to the other machines? What can you do with that? When you have an algorithm, for example, these days, they're all running slightly customized to your airport. The algorithm we have deployed, we deployed at Narita, is different than the algorithm we deployed at San Jose, because in Narita they have a lot of lighters and razors. In Sweden they have a lot of tins of fish. So just like operators learn based on what they're seeing in real time, these systems, the expectation needs to be that these systems are going to be tailored to those different environments if we want to optimize for maximum security and not make the operators and everyone else feel like they're stuck with a system that they have to work around by putting more money into training that could have gone into the development life cycle.
Yeah, I think to support you, what you're trying to explain is a differentiated security screening process, and I think it goes bottom to risk assessment. I think what states needs to do more is to do a risk assessment and then come up with exactly what threat that is being mitigated, and then once you establish the threat that needs to be mitigated as a state, then you know what technology would best fit that state and or would close that gap of that particular threat. So I think that is where it should start, and then coming up, of course, with the best technology that a state could be able to. The resources are affordable to employ that kind of technology, and then of course, as he says, a technology that can be integrated with the other systems, because again, if you buy a technology that is standalone, then it means probably you may have to change all your other systems. Yeah.
And as we move towards not only the prize competitions, but algorithm development being very important for data analysis, the area that the international community needs to come together on is not just standards, but data sets, relevant data sets that can be used for training, can be used for prize competitions, and can be used to put out there to develop algorithms to make the detection better.
So quickly, I'm going to turn to some questions from the audience in just a second. I want to make a brief comment. If you remember those concentric circles on the image that showed good ideas and seemingly bad ideas, and then in the middle, the sweet spot, going after the seemingly bad ideas and trying them and finding that sweet spot requires skin in the game. It requires you taking on some risk, either as an airport operator, as a government regulator, or as a technology vendor, right? And so there's a whole conversation to be had around skin in the game and taking on that risk, and how we establish structures to make it okay for people to take on that risk. So I have a question before we go to the questions from the audience for Sarah from the FAST program. How do you guys deal with the bucket of money or the portion of funding that kind of goes to the crazy, right? That you reach beyond the traditional or what we're trying to implement today, and you think about the deep blue and what could be seen as a really weird idea.
So for us, it's all about communication and really clear and open communication with the industry, airports, and airlines, and what they want. And it's thinking outside the box, as you put it earlier, about having the knowledge of what technology is out there, what's being used across different modes of transport, not necessarily in aviation, in other parts of the world and in industry that you wouldn't necessarily relate to aviation security, but actually there are benefits that can be adapted and used within our aviation security field. So we, as a FAST team, we're a very small team based in the UK, so we heavily rely on our relationships and collaboration with other government departments, industries, ICAO, people out there to help us understand and see that bigger picture. And it's mapping that together then with our technical experts within the UK and understanding where our gaps lie in our program. We know what the baseline is, we know what we're currently capable, where do we want to be? It's getting the advice from the policy leaders and understanding what that threat looks like 10 years down the line, what do we need to be aiming technology at? It's really understanding that future target.
So just to close out, I was told that we have 5 minutes. Great questions from the audience, but to address one, which I think is great, we're agreed on the need to do something to drive or accelerate innovation in aviation security. Assuming that we're good with the baseline, what's the next step? Regulations, human factor, capacity building. I think all of you have an important role to play. We always say, think global, act local. So when you go home to your jobs and you think about accelerating innovation, what is it that you're going to do day to day to do that?
No, it's fine. It's certainly looking at the problem holistically and not just focusing on the technology approach. As technology developers, we tend to be a hammer looking for nails, and we don't want to take that approach. Understanding how the new technology development may fit into a ConOps, may fit into an airport scenario and be effective, not just from a measurement aspect, but from a operational deployment aspect is something that I think low TRL researchers don't think about and should, and certainly the international community and ICAO can help educate low TRL researchers to think, okay, you've got a good idea, but ensure that you can move it towards something operational and not just be a lab oddity.
For us, it's about having that really clear image of, Dave talked about it earlier, understanding what technology really has a pathway and an opportunity to be taken to market, and investing in that and having that balance between what we invest in terms of lower level technology and then the more heavily developed technology that could potentially be used in the very near future. And I think when we look at things on a local level, it's understanding for us how it fits in terms of what you guys are doing. If there's eventually going to be an ICAO global standard, how does that fit for the UK? We've got a very different security outlook to certain different state members, and how we need to adapt that in terms of our technology drive is really important for us.
I think from an operator perspective, it's about the end user properly communicating with the technology vendor on what threat is there and what needs to be mitigated, and therefore what technology is required. I think that is very important.
So I think we need to look at the whole system. Everyone talks about curb to gate security. Now it's moving keyboard to gate. So looking at different ways you could develop sensors or a system of systems that can encompass things prior to the checkpoint. Looking at sales of materials, sales of precursors, screening for unstructured crowds, perhaps a parking lot or when you walk into the airport, instead of focusing on the specific detection technology at the checkpoint.
I think it's two things. I think one is what we mentioned earlier, which is how do you have standards for security that you can measure a baseline against? If you deploy, an AI that detects more guns and knives, what does that mean? It's easy to measure dollars saved and throughput increases, but it's much harder to measure increases in security capabilities. And I think the second is realizing that there is an opportunity to invest time and money and effort into technology today to influence how you want it to work for you in 2 years. So today, our algorithms can detect guns, knives, lighters, and some other threats. Our goal is in 3 years, to be able to detect the whole PIL outside of explosives. And I think when we get there, it'll be very exciting because operators will be much more effective at finding explosives. But how can we align stakeholders with that long-term vision?
Great. So I think that we are out of time. A huge thanks to our panelists today. I would say AvSec Innovation Accelerated, #. Thank you for participating in the event, and we're here for the rest of the week, so if you have any questions, feel free to approach us. Thank you.
And a huge thank you for our moderator for doing such a great job for us. Thank you, Anne-Marie. Okay, we now have the family portrait. It's always a nice moment in the event. As we're taking the photo, I was looking at the survey, the polling, and it was interesting that 59% of you were suggesting that communicating the advantages and the benefits of new technologies is the way to go in the future, of course, with other aspects of it. But communication remains one of the top objectives and goals that we should have in this area. And by the way, when the questions are not posted or were not available on the large screen in the hall, they're available on the app, so you can go at any time during a session on the app and see the questions that are being put forward. Okay, I now have a brand new iPad. Thanks, Anne-Marie. Okay, just before we go for lunch, we have another very interesting SkyTalk, and it would be delivered by Monsieur Nicolas Wackley. He is in the cargo and mail screening equipment with Chia as the global solution manager. So we're very much looking to your presentation. Et voilà, Monsieur Wackley. Et voilà. Tout est beau.
Perfect. Okay, great. So, good day, everybody. Thank you very much for attending the SkyTalk, our SkyTalk. So I'm very pleased to be here today, back in Montreal, which used to be my hometown for a long time. And I'd like to thank ICAO for giving us the opportunity to present to you today our solutions. So you went a bit fast. So most of you probably know us from these items. So we've been around for 50 years now. We are an Italian company, and we are well known in the airport industry for providing passenger security checkpoints. So walk-through metal detectors, handheld metal detectors, and more lately, liquid explosive detection systems, but also shoe scanner for metal and explosive detections. So we've been speaking for 45 minutes on passenger AFSEC. However, I'm not going to discuss that right now. So I'm going to do something a bit different for once, because we are also present into the air cargo screening environment. So air cargo screening is what is said to be by many experts the weak spot of aviation security. Part of this problem is that standard and best practices are not as well defined as they are for passenger security checkpoints. So for the next 15-20 minutes, I'm going to try to give you some information of what current technologies are, what they do, their advantages and limitations, and I'm also going to introduce to you our cargo screening solutions that have been around for the past few years, very recent technologies. So when it comes to air cargo screening and air cargo security, so the threats are not exactly the same as passenger security. When it comes to air cargo, we do not look about firearms, knives, or even explosives on their own. The threats are improvised explosive devices. In other words, the threats are assembled bombs. So bombs are made of explosive matter, detonators, trigger circuits, and also batteries has a power supply to trigger the detonation. So we're going to see that most technologies available for cargo screening are trying to catch one of these components, and where we stay, us, at CHEA. So here is a list of what is currently being done in the air cargo screening environment. So we're going to go through each of these technologies very quickly to focus more on our solutions. So I'm going to start which is probably the most known. So we talk about dual view X-ray transmission, so non-computed transmission. I'm not talking about computed tomography, CT scans. So these devices, which are the most spread across the air cargo screening environment, are generating images, and you have a human operator trying to find actual bumps within the commodities, goods being screened. So advantages of these dual view X-ray transmission, as a first, very large aperture are available with 1.8 by 1.8 meters being approved by most civil aviation authorities everywhere. Then, because they are based on X-ray and generating images, they actually can allow a wide variety of commodities. And last but not least, they are reasonably affordable in terms of purchasing costs, as long as we do not go too high in the large apertures and high power generators. So limitations on these technologies, they have very limited detection capabilities, and especially with poor performance on IEDs. So this is due to the very dense items going through and difficulty to penetrate actually the commodities when they are configured in skids. So they do have significant maintenance costs, and in most countries they require a license for the use of ionizing radiation. And last but not least, again, they do rely on human operator interpretation. Now, explosive detection systems, so for standard 3 and more, so these are actually X-ray based technology taking care of analyzing the packages going through and detecting explosive matter automatically. So they have automatic detection, so no need for human operator, and you can screen a wide variety of commodities, which is definitely a good advantage. But they are price restrictive with a high maintenance cost, high purchasing cost, very limited in terms of shipment size. Currently it doesn't go more than 1 meter by 1 meter, so forget about skids. And they also require a license for use of ionizing radiation with a significant false alarm rate. So then, with that, we talk about explosive trace detection. So that focus also on explosive detection. They have fully automated detection. They are quite affordable compared to the previous ones. They do have a low false alarm rate, and they perform very well as a second level screening device. As a first level, that's definitely not the best technology to use for the following reason. First of all, you need to open the shipment, does generate a long processing time, not adapted for all type of commodities. Forget about wet and humid goods with explosive trace detection, it's not gonna work. And it does depend on sampling performed by human operator. So again, we come back to what we've been discussing with the panelists and basically providing good training to the operators. So then explosive detection dogs, again, focusing on the detection of explosive by sense. So advantage of having the cost evenly distributed since you pay for a service, quick processing time, and very reliable. However, they are not always available at the airport or in the cargo area. They are not approved for use everywhere in the world. They do require significant maintenance and training for both the dog and the handler, and they are not adapted to all commodities. So this being said, us, CHEA, where do we fit in there? So over the past 2 decades, I would say, we've been working on what they call metal detection equipment. So think about a very large walk-through metal detector for cargo screening. So basically it started pretty much 20 years ago when the first requirement for using MDE occurred in Europe and in France, to be accurate. In 2000, the first deployments of metal detection equipment occurred for screening cargo packages. And then in the middle of the 2000s, basically North America with the TSA and Transport Canada on a combined project required CHEA to work on something that could screen pallets and to think of a technology, a device that could perform the same thing on small packages but at the skid level. So in 2015, the European Civil Aviation Conference branch of ICAO introduced the MDE as fully part of the common evaluation process, and nowadays, in 2018, our solutions, the Adversaries, is currently approved and qualified for use in the US, in all of Europe, and in Oceania. So basically, the problematics we started with, the screening of dense cargo revealed itself quite difficult when using methods such as imaging or trace detection for the reason I've been discussing. When you see on the screen, so on the left, you can actually see a picture taken from fish skids. In the center, these are carrots, and on the right, actually bundles of magazines. So these are X-ray images, and you can see right away the problem. There is way too much dark in there, meaning that the X-ray, even though very powerful, did not penetrate the whole skid, and eventually make it very difficult for a conscientious and serious operator to make a security decision. So we did have a requirement to use technology more suitable to these type of materials in order to detect threats more efficiently and more accurately. So, and this is how, basically coming back to the air cargo threats, when most of the other screening methods, they focus on the explosive matter itself, we focus on the metallic components which are necessary to trigger the bomb. So detonators, trigger circuits, and batteries. So after all, that's what we do. We are experts on the electromagnetic field, and we use this part of the physics to detect threats. So metal detection equipment, you detect detonators and the metallic components. So batteries, meaning also lithium batteries, any type, alkaline, whatever. So here are our series, the MES technology. So you see on the left our small unit for package screening, and on the right this bigger but younger brother for screening skids. So operating principle is very, very simple. It does look like an X-ray, but actually it's a big metal detector. You just screen packages through without the need for an operator to actually check out any images, because there are none of them. There is an alarm in case of metallic presence, or the unit being cleared, the commodities being cleared in case of passages go through properly. In terms of possible applications, so obviously you understand that if it's a metal detection equipment, you cannot screen everything and anything with it. However, when you do have commodities such as perishable, so fish, meat, fruits, vegetables, whatever, live animals, print media, any kind of paper product, pharmaceuticals in bulk that are actually quite tricky when it comes to cargo security, liquids, plastic matters, wooden product. Basically, this is something that you can actually think metal detection equipment, and you can ask this kind of machine to be used and provide a very efficient security decision. So here you have actually two types of layouts that could be done. The small machines are quite fast with a very high throughput, up to 3,000 packages an hour. They can be fully integrated in line with a conveyor system, divesting system to oriented towards other type of technologies. The larger ones, because we talk about intensive heavy forklifting, a lot of movements, they tend to be standalone, but could be integrated in line also if the warehouse, the screening facility had the proper conveyor systems. So operating principle, very, very, very easy. So just like a walk-through detector at the airport, you go through. If no metal is detected, green light. If there is possible presence of metal detected, so possible threat detected, red light with an audio alarm. So here, this one is a video. I'm not sure. Maybe we need to press. No, it doesn't matter. Yes. So here you have the large machine actually performing a transit using so our biggest model, the MES 13200. So this is actually pretty much 800 kilograms of fresh salmon being packaged into these skids. So it goes through the machine, and once it has performed the transit, which is around 25 seconds, basically green light, nothing was detected in there. So as you can see, there is actually no one in the area checking any screen because it's not required. The machine makes the decision on its own, and it's the machine which is being reliable and liable when it comes to the security of the commodity itself. So on this one, it's the same pallet in which we actually we've hidden a threat. So now you see it's going through. Video jammed. Sorry about that. It's okay, no big deal, no problem. So what you should have seen was actually a red light. So on the next one, here we have something a bit different. So, yeah, no. So here it's in a fast parcel screening environment. So you see how fast the packages go through. So with this one is being cleared, the next one also. So with regard to what has been discussed before, actually, in this kind of project that we have with Express Courier, we are not trying to replace any technology in place. We're just trying to optimize their setup, combining different technologies. In this case, metal detection being something which is not very highly priced and affordable, it can be put as a first level. And we managed to clear more than 30% of the volume of an express courier being sent right away to the aircraft without having to be screened by explosive detection dogs, CT scans, or even trace detection. So in the end, these are the kind of things that are interesting for the industry when using this kind of technology. So what I would like you to remember about cargo metal detection equipment, so as a first, obviously, just like the name says, they do detect metal. They do not detect explosives or firearms, whatever. They detect metal. So advantages they have that they are obviously made to detect automatically, so you don't need any human operator to interpret any image or to make a security decision. The machine is reliable and liable for the result. They are quite affordable and they have a very low maintenance cost, which translate into a low cost of ownership over the life cycle of the equipment. Then they do have currently a very low false alarm rate, so you're not going to have the metal detector triggering an alarm every time you screen a pallet. And obviously, given the process and the technology, the sciences they use, they do have very high throughput. So as I said, the small machine can push 3,000 packages per minute with a speed of 1 meter per second. The large one can do 2 pallets per minute. So limitations, there resides into the technology itself. So it is only for specific metal-free commodities. Do not try to screen car spare parts with that. Obviously, it's not going to work. So, and they do require also specific metal-free packaging. So in the end, and to join what has been told before, we've been discussing about more training, more innovation. In my opinion, we already have, in terms of technology, a very good baseline of devices and principles that have been tested and proven on the field. So in my opinion, what can be done to improve things, obviously quicker computing time to improve throughput, but also improving false alarm rate. So then, just like I've been discussing for Express Courier, we have the opportunity to have different technologies with different principles working in this, with different physics. So we should try to combine technology, combine available devices much more, especially by increasing low-cost first filters and combine them like metal detection equipment and dual-view X-ray equipment with an auto-clear capacity, joining the gentleman who was discussing about artificial intelligence to clear or to unclear packages quicker. And then one of the most important, especially in the cargo field, just like operator might not be trained properly, when it comes to air cargo security, in my opinion, the stakeholders are not trained well to choose the best screening method with regard to their business core. So they are left to themselves the possibility to choose what they need to do. However, there should be probably more best practices determined by all of us. So I thank you very much for your attention, and if you need to ask me any question, our booth is just out there on the left, number 1. Thank you very much, everybody.
Thank you very much, Mr. Wakli, for a very interesting, as you say, complimentary presentation to what was said this morning. Well done. Thank you so much. Yes, we're breaking for lunch, and we will have about an hour for lunch so we can gather our strength for this afternoon sessions. The lunch is sponsored by Osprey, and their booth is near the elevator on the right as you exit the hall and go to the end. We'll see you back at 13:50, and yes, we'll ring the school bell just to give you an indication of when to come back again.